or moving an object or a shape in the coordinate plane. So you might have done some of this in maybe science, maybe. Any idea what the transformations are? What are examples of transformations? Turning it. So what else? How else could you say that? A rotation. Okay, cool. Anything else? Or a reflection. That's what we're going to talk about today. Trans what? Yeah, what's that mean? Perfect. Translation. We've already talked about one. With our eyes. Dilations. Okay. So all of these would be what we would consider transformations. We're going to break them down one by one. Okay. And then I think fourth or fifth section, you kind of have to try to do all of these at one time. Well, not at one time, but you do it all to the same object in one kind of thing. So the first one we're going to do is a reflection. So if you do a reflection, what do you do to something? Okay, you're going to flip it over something, right? So with all of these now, before we really talk about this, we want to talk about a pre-image and an image. I think we've brought this up before too, haven't we? The pre-image is the original. And that's kind of messes with some people's head when it says pre. Why is it the original, right? Why isn't it image and then like post-image? And then, so the image is the result from the transformation. So I can do this to anything, meaning any shape that I want. I can do it to a square, octagon, a triangle, whatever. So in the pre-image, they would tell you that you have triangle ABC, for instance. And you want to turn it into something, or you're not going to turn it into, but you could do a reflection, a rotation, a translation, or dilate it. And so then to show the difference between triangle ABC and the triangle of the image, there has to be some way of showing the difference between, because I'm going to still have the same vertices, A, B, and C. So any idea how they differentiate between the pre-image and the image? Yeah, the little comma. What did you call that little comma, do you know? So they're going to put this little, as Warren called it, an apostrophe, basically. Not really a comma, because the comma's down low, right? So it's apostrophe. But any idea what that thing's called? You just said it. This little symbol right here is called prime.
What's a subscript?
A subscript is a little thing down here. It's kind of like a comma. You got everything down there. I don't know. So the difference between this is triangle ABC. This is triangle A prime, B prime, and C prime. So I'm still talking about basically the same vertice or vertex, but I'm just talking about how I moved it. That makes sense? And that'll happen for the rest of the time that we're talking. So for there, then, we go into a reflection, and as somebody said, it is flipping the shape across a line. So obviously, this is going to be called the line of reflection. So this can be anywhere that we want it to be on our coordinate plane. Okay, it could be the y-axis, could be the x-axis, it could be any line, it could be a vertical line, it could be a horizontal line. All right. Basically, if you do this across some line, so if they say, I want you to flip it across x equals 1, all right, they would give you a shape, you would plot that shape, and then you would flip it across this line, and then decide what your new vertices are, and that's what you're gonna have to try to do for your assignment. Figure out what the new coordinates of your vertices are. So, first off, how do I graph x equals 1? To the right one, and then what kind of line is it? It's a vertical line, right? So if I'm going to do it towards x equals 1, here's my line. I first have to know how to plot that line, right? Remember, this is my x-axis, this is my y-axis. Okay, so x I have to go over 1, and it's a vertical line. So any line that has x is a vertical line. Any line that has y equals something, it is a horizontal line. Okay? If it has anything else, then you would have a slant, like y equals x. Okay? So basically, we're going to try to make this really simple for you. And if you're trying to figure this out over some random line, okay, you're basically going to just measure how far each vertex is from the line of symmetry. We'll call that the LOS. So we don't have to write that all the time. So the line of, oh sorry, not symmetry, the line of reflection. So we'll call it LOR. Okay, so I'm going to try to figure out how many lengths I am from each of my points, and it should happen exactly the same way. So it's not like I just take it and I pivot it around. Not like I take it on the farthest point of that shape and just pivot it on that one and flip it over. It's actually trying to measure the same thing. And so if this happens to be on, one of my points happens to be on this line, then I can use it as like an actual hinge where I can flip it over. Okay? If I'm going to do this on, or over, let's say over, the x-axis, okay? And they give me my coordinates, or you would have your coordinates plotted. To find your new coordinates, and this is where the challenge comes out. Make sure you pay attention. So if I'm doing this over the x-axis, to find my new coordinates, I'm going to keep all the x's. So whatever it started out with as my x, which part is my x in a point? Which number? The first number, right? I'm going to keep all the x's and multiply all the y's by -1. So, for instance, if they told me that triangle ABC was, A was at 2, 4. I'm just going to do 1. A prime then would be at what? If I keep my x and multiply the y by -1. 2, -4. And wouldn't that make sense? If my first one was over here, 2, 4, 2, 4, and I flipped it over that axis, all I'm doing is keeping my x the same spot, but I'm flipping it over that x-axis. Okay? Sorry, I should have went down. Should have went down. Okay. So then each one of those is going to happen the same way. So you keep the x's, you change the sign of the y's. That's about as easy as you can get it, hopefully. Right? So what happens if you think, or if it is making a reflection over the y-axis? What do you think we're going to do now? Yep. Keep the y's and what else do we do? Multiply the x's by -1. So essentially we do the exact same thing. So again, triangle x, y, z, and x is at 4, -8. What is x prime? -4, -8. And then obviously you have to do that to every single coordinate, but we're just showing you one at a time. All right. And then last but not least, so basically we're going to try to keep this real simple again. If we reflect over the line y equals x. Well, first off, what line is y equals x? If you had a graph y equals x, where would your line be on my coordinate plane? Where would I start to graph this line right here? What? At the origin, and then what's my slope? 1 over 1. So anytime that you, from here on out, see this equation right here, y equals x, it's that slanted line right there. Okay? So if I am asked to reflect something, again, let's make a triangle. Let's call it JKL. And they are going to tell me that coordinate J is at 2, 3. What do you think happens if I have this and I went 2, 3? If I want to flip it over, where am I going to go? If I'm going to take this and flip it over this way, what would I do with each of my points? Huh? Perfect. So, if you're going to reflect over this line, you switch the coordinates of each point. So you just flip-flop them. So, what's J prime here? Just flip-flop them, and we get 3, 2. Okay? So the first one, if they give me an actual line, I need to see where each point is from that line, and I flip it over that line, either up or down, or left and right, and then each one's the same distance away. If I do it over the x-axis, I keep all my x's, I multiply the y's by -1. If I do it over the y, same thing, but the opposite. And then if I do it over that y equals x, I just flip my graph, or flip my coordinates. Okay? Think you can handle that? All right, that's it. Let's look at a couple. Where are you going?
Backwards.
Okay. So basically, in this section right here, you just have to remember all these kind of little rules. And if you can remember the little rules, the quizzes are very, very simple. If you can't remember the rules, then it gets a little complicated. Okay? So here's my first one. Quadrilateral JKLM has vertices J, blah, blah, blah. Graph JKLM and its image over x equals 1. So they started plotting these points, okay, and then they drew x equals 1 right here, the big blue line. You see that? So here's where it gets a little confusing, but basically I'm taking that and flipping it over that blue line. Now I'm not hinging it on anything, I'm just flipping it totally. So you see how the M is actually a distance of 1 away? It needs to be a distance 1 away when you flip it to the other side. See how L is 1 away on this side? When you flip it, it's going to be 1 away on this side. My K's got to be 2 over. So when I do this, they're going to flip it, and notice, see how my M's are 1 away? My J's are 1 away, my K's are 1 away, but they're straight across from each other. So basically, it's not really like flipping it on a hinge, it's basically picking it up and flipping it over. That makes sense? So what I ask you to do then, instead of graphing this, and you can graph it if you like to graph, But basically, all I ask you to do is name each of the coordinates for the image. So in our case, you would have to say the points that the green vertices are on. So where is M? M is at what? 1, 2, 1. So M prime would be at 2, 1. That's my answer. So if you know how to do this, it's very simple and it's a lot of points. But if you screw up the rule, then you miss all of them, basically. You know what I'm saying? And so I think the quiz is worth like 45 points, but it's, as long as you can remember it, it's everybody gets an A plus or everybody gets, you know, if you forget that one rule, then you miss 3 of them out of that. Okay? So again, with the first part, here's my pre-image. All right, so I'm going to take it and I'm going to flip it over that blue line. What would L prime, what would the coordinates of L prime be? 2, -3. I love with that. What would M prime be? So basically, I'm just taking it and flipping it over that blue line. So what's M going to be? M's basically you're just going to take and flip straight up and over. So am I going to move from 0? No. How many do I have to go down? How many? 3, right? From this point to this point, I'm 3 away. 1, 2, 3. So from here, I got to go 1, 2, 3. What's this point right here? 0 what? 0, -5. That would be my M prime. What's J prime? So count from here to there, right? How many did I go up? I went 5 up, so now I got to go 5 down. 1, 2, 3, 4, 5. You can't even see my pointer. So where am I at? What's -2 minus 5? -7. So my J prime should be what? 2, -7. Exactly right. Let's see if we did it right. So here's my J. Did we get to -7? 1, 2, 3, 4, 5, 6, 7. Make sense? So first things first, I have to know which one's which, right? So what is my x-axis? The horizontal one. The x-axis is this one, right? So if I do actually ask you to graph, which I don't think I ever do, but if you do, you have to know that this is my x. But if they say to reflex around the x, what's A prime? 1, -1. What's this one? What's this one? See how easy it is? Right? Unless you forget the rule. So remember, x-axis, keep the x's. X-axis, keep the x's. Okay? So there's all my answers. All right? If they say y-axis, then I'm going to do what? Keep the y's and change the x's. So what's A prime? What? -1, 1. This one? Easy enough, right? What happens if I want to do, nope, not that one. Now we go back here and do the same one, but now we're going to do it across y equals x. Oops, sorry. I don't know what's going on now. It's on the fritz. Why won't they show me that one? There we go. All right. So now I'm going to flip across this. So what do I do? 1, 1 is still 1, 1. 3, 2 turns into 4, -1. That's it. And the proof is right here. Okay? Make sense? Hopefully, pretty soon. Then obviously on the quiz, you just have to remember which one's which. Aw. Hang on a second, I thought I figured these all out. Can you see that? Those would be the ones that you gotta do. And again, see where it says in the directions, just write the vertices? So just write the vertices of the new shape, you don't have to graph them. Even if it says graph it in the book. So those of you that are leaving on, or won't be here on Thursday and Friday, if you want to see, we can put those up right as soon as everybody writes these down.
So we'll have a second group tomorrow or Wednesday. You want us to turn in our assignment for Wednesday before we leave? Like one of us do Thursday before we leave.
If you have it done.
And then Thursday, the one from Friday.
If you get them done, that's fine. If you wait till Monday, that's fine. All right, so those of you that are leaving, there's Thursday.
The ones that are underlined on the bottom.
Right down here, yep. Unless you want to do all of them.
She said wrong. What?
And then Friday would be the quiz.